All right, this is chapter 19 of Advanced Statistics for Psychology and Human Factors. And we're on chapter 19. Actually, if you look on this, this says we're on chapter 20. We're going to be doing the analysis of covariance in this video. I've rearranged the order of these, so it's really 19. And by the time, if you look at this website, this will be 19, and this will be moved to 20. All right, so chapter 19, analysis of covariance, you can get all the materials. You should be able to get all the materials by following this link. There's some PDFs that have our images we've created along the way. There's some data that we'll use as a sample to do some analysis. And here's the R code you can download and follow along. And of course, as always, the entire course book is available at the top of this page, and a link is in the description of the video. The course book is available right here. So we're going to talk about something that if you've been keeping up in this course, you already know how to do, but you didn't know you knew how to do it. There is a class of models that were often originally thought to be a advance over analysis of variance. And so an analysis of variance is when you have oftentimes an experiment where you've manipulated some variable and you have multiple levels, maybe a control and an experimental level, and you want to see if there's a difference, and we could add maybe a second variable. So you have multivariate ANOVA, where you have a 2x2 design or something like this, and that would be a factorial ANOVA or multi-factor ANOVA, multi-way ANOVA. But what happens if you have a factor and you want to see if there's a difference, but you think that there's some other factor that you have collected that will impact this? So a really common thing might be to look at age, and so you say, well, or education or personality variable. And so you bring people into the lab and you don't know what their status is on any of these levels initially, but you know that they are, oh, sorry for that. But you do know that they're in either an experimental or a non-experimental group. And maybe you want to see whether that experimental manipulation had an effect, but you think maybe this other variable, which we'll call a covariate, will also have an effect. So for age, you might expect, if you're looking at children or if you're looking at older adults or throughout the lifespan, you might expect that very young children won't respond well to your training, and so there won't be a difference. But as you get older, there will be a difference. And so you want to see both to explain variability in your data, and also maybe to see if that covariate matters, you want to incorporate a continuous variable in your ANOVA. So this sounds all reasonable, but then if you think back to what we've been doing, we've spent a lot of time in regression modeling, including categorical variables. And so an ANCOVA is really just the same thing as adding a categorical and a continuous predictor to a regression model, except now we analyze it with the ANOVA table instead of looking at regression effects. Here's an example that we'll look at that it makes sense to think of whether there's a covariate and doing an analysis of covariance, or really incorporating an effect of a covariate into this really helps you understand what's going on. So the setup is that maybe there's 3 companies, and we've sent 10, I think 20 people, both men and women, to these companies, and they've gotten job offers at each one. And each of these people have a gender, and they've got a starting salary offer at these 3 different companies, but they each have different experience. And so we might want to see, well, is there a difference in how much the starting the starting job offer is for men versus women. And so is there a gender bias in pay, in starting salary, and things like that? However, we might recognize that each of these people has a different level of experience, and we can't really control for that. People have come in with different levels of experience, and so even if we saw a difference in gender, maybe that's because all of the men have more than 20 years experience and all the women have less than 20 years experience, and so they pay men more for that reason. Without doing the test, we can't tell if, when we see a difference, if there's anything like that. We also may ultimately be interested in if there's an interaction between experience and gender. And so because we're now talking about interactions between contrasts or interactions between factors, we'd like to make sure we use contrasts that are orthogonally coded so that we can incorporate those like in a type 3 ANOVA, because that really might make sense to do. So right away I'm going to change the contrast of gender to be polynomial contrast instead of the treatment coding that we used previously. And that is the default. So here is, I'll run this whole area, this whole set. These are, again, they're faked data. I really don't know what the real relationship is, but we've got sort of 3 different companies, salary 1, salary 2, salary 3. And if we look at, if we consider what they look like, and just look, say, do men make more than women, or do women make more than men? In each of these 3 cases, it looks like the starting salary for women would be around 55, and the starting salary for men would be about 60 in each of these 3 companies. And so, so that's a fact, but then the question would be, well, it's a fact, and we can test if it's reliable, statistically significant, and in each case, a t-test between these 2 shows, yes, here's a t-test, 0.05, well, this one's maybe almost statistically significant. At company 1, 0.05, at company 2, 0.01, company 3, 0.001. So we'd probably conclude that there is a difference between genders in these 3 companies. But now we want to think about what is the cause of that difference? And is there any reason to think any one of these companies is biased? All 3 of the companies are biased. In what way are they biased, or are they not biased? And so we already said, well, experience might matter. And so experience here would be a covariate. And so we eventually want to do an analysis of covariance because we're including experience as a covariate. That would be the terminology. So here's a plot of the 3 companies patterns, and you can see that overall, if you look at experience, women in this pool tended to have less experience than men. So women had 10 or fewer years, and men sometimes had less than 5 years, but had up to 20 years. And so if starting salary is dependent on experience, then you might expect to see a difference. But it looks like some different patterns here. Here, maybe we can draw a straight line through all of these, and we would, let's see, we might be able to draw that straight line, and so we say, well, the difference in gender could be completely accounted for by experience. So maybe that's, in this case, the best case scenario. This company pays only based on experience, and they don't care about gender, even in implicit biased, unbiased ways. And so they may have a fair practice. Their starting offer is only based on experience. But here's one where it looks like for equivalent levels of experience, men are making more money. So maybe there's one line here and another line here. And so maybe there still is an effect of gender even after experience is accounted for. And here's the third case, which is maybe even worse, because if you draw a line between these, it looks sort of like this, and if you draw a line between these, it looks steeper. So now it's as if for the same level of experience, maybe men make more, but that difference increases over time. So so this might even be worse, that not only are women making less for the same level of experience, they're gaining less for every year of experience that they have. So can we develop models that test between these or look at these? That's the basic goal of the ANCOVA. Well, it's not difficult to come up with, I guess we'll mix together LM and ANOVA models here, but typically we'll build them with LM so we can look at the coefficients. So here is a linear model just looking at salary by experience. And you can see that there is a slope here. We already knew that. And to do we could do an ANOVA model of that, but then I can incorporate gender and experience. And I can do an ANOVA model of this. And now you have to think about, well, what type of ANOVA do I want to do? Because there's no interaction, a type 2 or type 3 are not going to make a difference. But, again, we probably want to know the effect of gender after experience is taken into account. And that would be the standard type 3 or type 2 ANOVA. So we look at gender in the context of gender and experience. We look at gender and experience in the context of experience to find the effect of gender. That's this test, and it has an F value that's for salary 1, that's this group that's very low, a p-value that's very high, so there is no effect of gender once experience is accounted for in this data set. And so I could do that as a type 2 ANOVA. Right here, I get the same numbers. And it says there is no effect of gender once experience has been accounted for. And even though this is an ANOVA table and experience is a continuous predictor, it's fine. It uses us as a continuous predictor and it doesn't cause any problems. So there really is no specific ANCOVA function. You just put a continuous predictor into an ANOVA and it becomes an ANCOVA, or what people call an ANCOVA. Okay, so that's in this case. We see that experience has an effect, but gender doesn't have an effect once we account for experience. I guess we could have done it the other way. If we did just a regular ANOVA, if we did an AOV model, so we can shortcut it and say AOV salary 1 by, now the order is going to matter. So if I did this, we find experience works, and that's it may be exactly the same model, but if I reverse these, here we're comparing gender to the intercept-only model, and now we see an effect of gender first, and then experience once gender is accounted for. So this is probably not really the model you're interested in, but it would be really easy to run a test with this model and conclude that there's a gender bias when in fact there probably really isn't. So you have to be aware of how these orderings happen, how this AOV model runs the type 1 ANOVA, which is sequential, and so it's going to depend on how we enter these. Let me put a note. Where did I? So we'll just call this a type 1, wrong, type 1. Really, this here we're comparing experience to the intercept-only model, and then gender to the experience and gender model, or gender and experience to the experience model. And so this also probably isn't the right one to do, although it's closer to the right one. Okay, what about in the second one? We can do the same thing here. We'll do a type 2 ANOVA of experience alone. We see that experience alone matters, but that's not really what we want to think about in an ANCOVA. Here we can do the type 2 of salary by gender plus experience, and now we find that there is both an effect of gender and experience. So here is an effect of gender once experience has been accounted for. So in this ANCOVA or in or ANOVA model, we're really finding a gender bias effect. And just to see what these look like, let me put these one at a time. So here is that original data, and I'm actually plotting two lines, one for the men and one for the women. And here I plot two lines, one for the men and one for the women, and because the ANOVA model has no interaction, these are guaranteed to have the same slope, but they have different intercepts. And so here, this is basically what the model's saying, is that once I account for the gain in salary by your experience level, there's still a residual effect of gender. What about the third company? Again, we can look at experience alone. We could see that. We could put gender and experience and do a type 2 ANOVA. And now we see both of them together as well. And I could plot these. And this looks different, but now if you look closely at it, we see, oh, maybe we're sort of under predicting here and over predicting here, and over predicting here and under predicting there. So actually maybe these are diverging. We haven't tested that. This model, this standard ANCOVA model, is just contributing an identical parallel effect of these two factors. So what about the interactions? I think it's usually pretty reasonable to try to do the main effects in an analysis of covariance first and establish what they're like before you start looking at interactions. Because if you have an interaction, it becomes sometimes if you have an interaction, especially in an ANCOVA, it's not really clear if the main effect makes any sense at all. But so you can look at them, and then at the end you have to sort of figure out how to interpret all of this. So in the first case, there's no big deal here to add the interaction. But we do have to think about how we want to test these. What is the type of ANOVA we want to use to test these? And if we go back to our model lattice, now this starts, you have to start thinking about this. So we have this interaction term here, and the interaction term, it would make sense only to test in comparison to each individual main effect. But now, does the effect of gender matter if there's an interaction? So do you want to test the effect of gender in comparison to the effect of the interaction, or do you want to test it down here just in on its own? So the equivalent of a type 2 ANOVA would be testing, well, B would be experience. So you test experience on its own, and then you'd test this interaction. But maybe you want to test experience in the context of the interaction. So does experience have an effect after you consider that interaction? And I think it might make sense either way. But let's see, because I did the polynomial coding, we could do either a type 2 or a type 3 ANOVA here. And either might make sense. So I could do this ANOVA, and we can see here, and this is what we found before, that there is no effect of gender. There is no interaction. But now this gender effect is being considered after the interaction is in comparison to the model with the interaction. So it's like the experience plus gender experience interaction versus the experience, gender experience and gender. Those are the two models we're comparing to get that. Okay, so in this case, the interaction is not significant, and so the choice between type 2 and type 3 doesn't impact our conclusion about the interaction, but it does impact our conclusions about these other things. And it may really make a difference, especially if that interaction is significant. So in the second case, we can do the same thing, and we see this gender and experience are again both significant, just like they were before. Oh, I'm sorry. Gender was not significant here, but now gender is significant, just like it was before. And it's even, these are both significant even in the context of accounting for the interaction, which happened to be not significant. So maybe this is a slightly more powerful test, that even when you account for the fact that these effects might differ, you're still seeing an effective experience and you're still seeing effective gender. Again, we can look at the third case. And now we can do type 3 ANOVA, and we see that this is significant, and they're all three significant. But let's say if I want to do a type 2 ANOVA, we can, these numbers change, and sometimes considerably. This F value well, they're both really, really large, but it gets much larger. This gender F value also gets much larger. So, this was fake data, and it was pretty strong. So, but there certainly could be conditions under which the test you do is going to give different results because it's really asking a different question. To show what that interaction is, I'm just going to plot that here, and we can see that if we allow these to have separate slopes, then not only is experience a covariate to pay, but there's a experience by gender interaction. And in this context, you might not even, it sort of makes sense to ask if there's a gender effect even after the gender by experience interaction is accounted for, and there is. But it's also worrisome. It would be worrisome to find this gender by experience interaction, because it means that not only is there a gender sort of decrement that scales, the more experience you have, the farther behind you get. Okay, so that's the basic notion of the ANCOVA. Within the file, we also have an exercise for a new data set. We'll cover that in class, or you could work through it on your own as an example, but I won't do it here. And so all of this sort of requires you to understand main effects and interactions in the ANOVA, and it turns out that you can also do main effects and interactions between categorical and continuous variables, and the interpretation is very similar, and the understanding the lattice is very similar. And on the other hand, if someone says, well, we need to do an ANCOVA, it's something that is, you might have thought, well, that's a new analysis, I don't really know how to do it. But if you've done regression with categorical variables and mixed categorical and continuous variables together in a regression, it's really the same thing that you've done before, except it's looking at it within an ANOVA table rather than just the significance in a regression, or AIC or BIC scores in a regression to do variable selection. All right,